Although creating light map UVs for every static mesh in your level may sound like a lot of work to get through, we do actually have a couple of options available to us for getting it done as we work through our project. The first would be to manually add a second UV channel in a DCC application, such as 3ds Max or Houdini, and then make sure that every part of the mesh we are working on has a unique UV cluster or island. An approach that probably gives us the greatest artistic freedom and control, but one that is also potentially the most time-consuming. We could also create our light map UVs right here in Unreal if we wanted, with the engine actually making it a fairly quick and painless process. The easiest approach being to check the Auto Generate LightMass UVs option as we import our meshes. With an Explorer window open then, we can see that inside the project folder, so Global Illumination 4.19, Content and FBX folders, we already have an FBX mesh ready and waiting. If we click and drag this onto our Unreal Content browser, after a few seconds, we should see our cursor update with a plus sign appearing next to the cursor icon. Once we see that, if we let go of the mouse button, Unreal will start the import process for us and pop up the Import Options dialog. Inside the mesh rollout, we should see an expandable arrow which, if we click, shows us all of the options that are available for the incoming mesh, one of which is a checkbox entitled Generate Light Map UVs. Let's uncheck that for now and click to import so that we can see how we might also go about creating light map UVs from inside the asset browser itself. Now just be aware that we may need to close out any message logs that appear here. Double-clicking on our newly imported static mesh entry should launch the asset browser for us, whilst dropping down the UV button flyout should show that we only have a single UV channel applied. To fix this, we want to come to the Details tab and again locate the LOD0 rollout. In here, we have our build settings rollout that we can expand if needed, and again see the same Generate LightMass UVs option found in the Import dialog. Let's click to enable that, and then click the Apply Changes button. By default, Unreal will use the UV mapping found in the first or default channel, which reminds us that a proper job done on our UV unwrap in a DCC application can both save us time and hopefully help give us a better final result. If we check the UV drop-down again, we should find that we now have a second UV channel showing up. We have a min light map resolution option here that, as we increase to, let's say, 1024 and reapply our changes, enlarges the UV clusters so that we can squeeze as much quality out of the light maps as possible. We can even force a resolution change to an object's light map UVs if we wanted. So let's add our object to the scene, and with grid snapping set to 1, place it on our floor. One way to force a resolution change is to select the object, come to the Details tab, and after scrolling to find its light mass settings, click the Override Light Map Res option, meaning we can now set a higher light map resolution for just this object if needed, or if we have multiple objects selected, we can change the resolution for all of them at the same time. As doing this can greatly affect build times though, we will only want to add a resolution increase to objects that are in areas of the scene that have high contrast changes in lighting, such as transitioning from a patch of bright sunlight to a shadowed area. Of course, using the very same controls, we could also go through our scene and set less important objects to have as low a light map resolution as possible, which would hopefully help balance lighting build times. The only objects that I have changed in this way here, as compared to the original realistic rendering project, are the walls, floor, and ceiling geometries, which as you can see have been set to a resolution of 1024, the doors, which have been set to 512, and the carpet, curtains, and tables, which now have a value of 128. These objects have been set to a higher resolution in order to help make changes from the values we adjust easier to see as we perform our lighting builds. Again, do feel free to set these as high or as low as you like. Although, if performance is an issue when creating light map UVs, then we may find ourselves needing, depending on object density in our scene, to lower some light maps to as low as 8x8 or 16x16 for smaller objects. Now, keeping in mind that the lower the light map resolution we use, the more padding we will need to leave between the UV islands in order to help prevent light bleeding from one island to another. The padding that we may see around the edges of the light map UV layout isn't actually needed, as LightMass automatically adds enough padding around the edges to prevent bleed artifacts by default. When creating light map UVs in a DCC application, it is good to keep in mind that the more UV islands we have, the greater the chances of lighting artifacts appearing. Whenever possible, then, we will want to try and keep any edges connected on the visual mesh connected in the light map UVs as well. As an example, in the UE4 documentation, you can see that this first object here is using lots of unconnected UV islands in the light map, and so is causing the mesh to display drastic changes in lighting on each face of the geometry. Whilst the second object has connected as many edges together as possible, especially edges that are visible to the user, thus giving the light map greater consistency and quality across the geometry surface. If we are instead importing objects into Unreal using Epic's Datasmith toolset, then just as when importing an FBX into Unreal, we can again generate light map UVs automatically by putting a check in the relevant box. Although UV creation may not be the first thing on our minds when looking to create good lighting and GI in Unreal, you have hopefully grasped that it can make a huge difference to the final product, possibly the difference between an okay looking and a fantastic looking visualization.